Now we are going to see another concept of functions. So till now we saw relations. Now we are going to define what are functions. So here a function f from a set A to set B is a special type of relation. So here there is an assignment of exactly one element of B to each element of A. So this is the speciality of this relation to be a function. Here f of A equal to B denotes that B is the unique element from the set B assigned to A from set A. So here B is called as the image of A, while A is called as the pre-image of B. So here A will have small a, B will have small b. So here A is related to B in the function f, and here A is called as the pre-image of B and B is called as the image of A if AB is in the function f. So here, if there is a relation f from A to B, then the first set A is called as the domain, while the second set B is called as the codomain. The same thing is given here. The domain of a function is defined as follows. Let f be a function from P to Q. Okay, P to Q. Okay, P cross Q. Or if I can define f from P to Q, then P is called as the domain of f. Then Q is the codomain of function f. Now, what is a range? If f is a function from set A to set B, then the range of a function is the set of all images of A. That means A में जितने भी elements है, उनके सारे images जो B में है, उनका set is nothing but the range. So here consider this diagram which denotes the function f. Here we have two sets x and y. So f is a function defined from x to y. Here x contains elements a, b, c and y contains x, y, z. So here the domain is nothing but the set a, b, c. Codomain is the set x, y, z. What is the range? So the range is nothing but the set of all images of the elements in the domain, that is x. So x के images कौन से A is related to x, so x is an image of A. Then B is related to Z, so Z is an image of B. C is related to x, so again x is an image. So here this is my range. Okay, so this was about the definition of a function. So in order to understand clearly how we can determine if a given relation is a function, consider this example. You have to determine if the given relations R1, R2, R3 are functions from A to B. So I have been given set A, set B, and you have to determine if R1, R2, R3 are functions. So let us consider R1. So for R1, I'll define domain ABC, codomain DEF, and from R1, I will show the pairs. A is related to E, B is related to D, and C is related to E. So in order to determine if it is a function, what I'll have to do first I have to see that every element in domain appears in the relation. Is this property satisfied? Yes. A, B, C all are coming in the tuples of the relation. So this is satisfied. Second is there should not be any mapping of the form 1 to many. Okay. So here that means one element from the domain should not be related to many other elements in the codomain. So is this property satisfied? Yes, because every element in the domain A is related to unique element in the codomain. One to many nahi hai. So A is related to E, B is related to D, C is related to E. Okay, multiple elements can be related to same element in the second set. As you can see, A is related to E, also C is related to E. That is fine. But one single element in the domain should not be related to multiple elements in the second set. That you have to take care. Similarly, second set. For second relation, A is related to, the codomain here is different. It is 1, 2, 3. Okay. So here A is related to 1, A is related to 3, B is related to 2, and C is related to 3. So what about first property? Is it satisfied? Yes. Every element from the codomain appears in the relation. What about second property? It is not satisfied. Why? Because A is related to 1 as well as A is related to 3. So R1 is a function, R2 is not a function. What about R3? R3 is also not a function. Why? Because first property is itself not satisfied. C does not appear. In this way, you can determine if the given relation is a function.